Good evening to everyone. My name is Ankita Manabela from the Computer Engineering Department. Today I am going to present the topic optimization of a loss function and the best fit line using the gradient descent under the subject of exploratory data analytics. Then first we see the introduction to the gradient descent. Gradient descent is a mathematical optimization algorithm. Its main purpose is to reduce error in a model. In a simple word, when we try to draw a line that fits the data points, the line may not be perfect at first. Gradient descent helps us to adjust the line step by step so that the error between the actual value and the predicted value become a minimum. So it helps us to reach the best fit line. Then regression equation. In a linear regression, we use the equation y is equal to mx plus c. Here, y is an output or the dependent variable, and x is an input, or we can say the independent variable. M represents the slope of the line and the c represents the intercept. So our objective is to find the best values of a m and the c so that the line fits the data accurately. Then we see the loss function. To know how well our line fits the data, we use the loss function. The most common loss function is a mean squared error, also called as an MSE. It calculates the difference between the actual value and the predicted value. If this loss predicted values, if this loss value is a small, it means our prediction is good. So our goal is to reduce this loss value as much as possible. Then we see the optimization objective. The main purpose of gradient descent is to reduce the loss function. To do this, we keep the adjusting m and the c. We move them in a direction where the losses decreases. The amount by which we adjust is controlled by parameter is called as a learning rate. If learning rate is too high, means we may miss the minimum. If it is too low, the process become very slow. Then we see the gradient descent formula. We update our parameter as a m is equal to m minus a into sigma of j divided by sigma of m, and c is equal to c minus a into sigma of j divided by this sigma of c. Here, a is a learning rate, and the sigma of j divided by sigma of m and the sigma of j divided by the sigma of c represent how much the loss changes with respect to the m and the c. We repeat this updates until the loss stops the decreasing. Then working of gradient descent. Steps involved are, first step is start with the random values of a m and the c, make a prediction and the calculate loss. After that, find how the loss changes for a m and the c, update m and c, and repeat these steps until the best values are found. This process keep improving the best fit line gradually. After that, the type of gradient descent. There are three types of gradient descent. First is a batch. First is a batch gradient descent. It will use the entire data set for each update. Second is an stochastic gradient descent. It will use one data point at a time. Then mini batch gradient descent. It will use a small group of a data point. In that, mini batch is a commonly used because it balances speed and accuracy. After that, visualization of a best fit line. As a gradient descent, update the slope and the intercept. The line adjusts slowly. It keeps the reducing the distance between the predicted and the actual one. Finally, when the loss is a minimum, we get a best fit line. So here in a picture, you can see the best fit line. Then advantages and the limitation. Uh, Advantages are simple and effective, and work well even for large data set. Limitation, can get us stuck in a local minima and sensitive to learning rate. Also, another is may requires more time to converge. After that, real-time application is there. Gradient descent is widely used in linear and the logistic regression, also used in neural networks, image recognition, natural language processing, financial forecasting, and the prediction the models. Mm, and the last is conclusion. To conclude, the gradient descent is a very important algorithm in a machine learning. It helps us to minimize the error and find the accurate model parameter. Understand the gradient descent is initial to build a better predictive model. So, thank you so much.